Welcome back, everybody, to the second episode in my Animating in Desmos series. And no matter where you are, what time it is, I appreciate that you're watching this video, and hopefully you'll learn a little bit of something new about Desmos and math and animating. So today we're going to be looking at how to make a continuous GIF almost in the graphing layer of Desmos. Something that cycles through and repeats, and we're going to actually, by the end of the video, hook it up to some of the other ideas that we did in my first video. So if you haven't checked that out, I'd encourage you to go ahead and find that video. And if you want to see more stuff like this in the future, click subscribe so you don't miss any new stuff that I put out. So first thing that you might want to think about as you're approaching this is very similar to how you might start a video. And so we're going to be doing a couple of frame-by-frame animation things, and so you're going to need a picture that makes sense in that style of thinking. The second thing is you'll need to know a little bit of math about the mod operator. Mod is kind of something that's not taught in school, but it's really cool, and we'll get more into that. Floor function is also something that we're going to use a little bit. So mod and floor, two unusual types of math that get applied here in this situation. And then the last thing is that this is always able to be put together with other ideas. And so if you've watched that first video and you know how time kind of flows, this video is going to have two types of time combined together, and you can do a lot with that. It's pretty exciting. So let's go ahead and let's get started. The first thing that we're going to need is another folder. And again, like the first video, this is my background folder. And it just kind of puts all the stuff kind of behind the scene and preps for what you see behind our character. And so I thought for this video I would do kind of a dragon theme. Our second folder is actually going to be our character. And I know in the last video we did the math stuff first, but because this is a GIF that is continuously animated, I think the character is the most important thing to focus on here. And so while you are in this folder, I'm going to go ahead and press enter a couple of times because we're going to import the images that we're going to string together. And I did these in Photoshop, and I manipulated the dragon's wings so that it looks like he's flying. So I have an up swoop and a middle swoop, and then when his wings come all the way down. If I can get that dropped in. Okay, now when we do this animation, it is actually easier to have 4 pictures instead of just the 3. Your eye will only really identify the 3, but we have up, middle, down, and as I was trying to think of the math when I came up with this type of animation, it's easier to go up, middle, down, middle in 4 as a group than it is to go up, middle, down as 3, and then somehow get back to the middle before starting over. And so I have 4 different spots, and I just need that middle picture at the end as well. And so it's going to cycle through 1 frame, 2 frames, 3 frames, 4 frames, as opposed to just 1, 2, 3, and then back to 2, and then 1, 2, 3, back to 2. So the type of time that's going to make all of this work, I like to name it something different than just overall time. Because this is always playing, I am going to name this GIF time, and we can start GIF time at 0. And it doesn't really matter what you put it at right now. One of the options that you can select here below the play button is to play indefinitely, which, if you're creating a GIF that never stops, is exactly what you want. Keep it at 1 times speed. We'll go ahead and we'll adjust manually the speed that we want later. But right now, if I play that, nothing's going to happen because I haven't really hooked anything up. The piece that's going to make everything work, the engine behind the GIF almost, is what frame we are on. So this section with frame is actually going to be using the mod operator, which mod is what's left over once you do division. And so I'm going to go ahead and I'm going to take my GIF time. I'm going to mod that by 4. And so that's whatever's left over when you divide by 4. So right now it says 0 divided by 4, and the leftover, the remainder of that's 0. But if I play this and I get into, the 1.5 second range, if I divide that by 4, it's 1.5 seconds. What's interesting, I'll play it and just let it kind of go here in a second, is that once you get past 4, you'll notice the frame itself drops back down. And so you're always between 0, 1, 2, 3, and then back to 0 again. Now, one thing that I don't like, you can't really have a frame 2.7. And so what we need to do is we need to take the floor of this answer. And floor just basically takes the number and floors it down. It smushes it down to the whole number. It kind of gets rid of the decimally part. So I'm actually going to go ahead and floor GIF time before it ever gets modded by 4. So now you can see it's a whole 2 amount. So 14 divided by 4 leaves a remainder of 2. And if I play this, 0, 1, 2, 3, back to 0, 1, 2, 3. And it's not very exciting, but this kind of is the action that we need to cycle through those 4 different pictures. But in my head, 0, 1, 2, 3 don't really match up with the first frame, second frame, third frame, fourth frame. And so in order just to get it matching it maybe a little bit better to how you would say this, I'm going to add 1 to this so that the 0 plus 1 starts us at frame 1, and then frame 2, frame 3, and frame 4. And it just cycles through 1, 2, 3, 4. Unfortunately, this is still a little slow, and so I'm going to go ahead and speed it up, because right now each second is 1 frame, so it's 1 frame per second in real time. So the thing that I'm going to have to kind of make is a speed. Maybe I will call this GIF speed, because we might have speed later. And so the GIF speed might go anywhere from 0 to 10. Oops. We should go by ones. Not that that matters. So 0 speed means it doesn't move. 1 is just 100% speed, just the same as it was. Double speed, triple speed, quadruple speed. So I might speed this up by 5. And we need to, in order to get this moving along a little bit faster, multiply our GIF time by the GIF speed. So when I play this now, you can see 1, 2, 3, 4, 1, 2, 3, 4. It's playing a little bit faster. So let me pause that. Right now, our animations aren't really doing anything because we haven't hooked our pictures up to the frame yet. In order to do that, we're actually going to be changing the opacity. If you remember from the first video, opacity is whether you can see the image or not. 1 is you can see it, 0 is it's invisible. And so in order to get this to turn on and off appropriately, we're going to make a conditional statement. And conditionals in Desmos start with the curly brackets. Essentially, you're making a command or a rule for it to follow. And so what I want it to look at is the frame that we're on. And when the frame is 1, since this is the up position of the wings, I want the opacity to be 100%, to be full, versus if it's not frame 1, I want it to be invisible. And so you put the true condition or the true result first, and then you put a comma, and then the false result after that, and close it off with a curly bracket. And you'll notice one of those pictures disappeared. I'll copy this so it's a little bit faster, but in each layer I'm going to change what frame I want it to be turned on at. So frame 1 versus frame 2. Coming down here, this is going to be frame 3. So if it's at frame 3, turn on, otherwise turn off, be invisible. And so the last one will be frame 4. And you'll notice this actually pops up because the frame that I'm currently on at the moment is frame 4. And if I play the GIF time, you can see that it goes up and down, like a dragon would really fly in real life or a video game or whatever, which is so cool. The one thing that I might not like about this, the dragon seems fairly large. It would be nice if I could change his size. So I'll make a variable overall with size. We'll just go 0 to 10. And so size is going to be the width and height, especially since that's kind of interesting. Especially since I made these all to be square pictures, square images, 10 by 10s. It works out really nice that I can just copy and paste the size as much as I want. Okay, So now that I have the size inserted into the width and heights, you can see that my dragon got really small, and I can manually adjust it a little bit to be however big I want. So yeah, that seems about right. It doesn't even have to be a whole number. So that's how you make a GIF in Desmos. You have to use the mod function to cycle your way through each frame. If you were doing a longer GIF, maybe it was 10 frames, you would need to mod by 10, and then that kind of works itself out to give you one per each frame. The extra thing that's kind of nice to have in there is a little speed controller, and that way your GIF can move a little faster. It's not one slide per second. So if that's where you want to stop and you learn something new, that's awesome. I'm glad that you got a little bit out of this video that hopefully will help you with your projects. But I kind of want to go a little bit further and show you how to layer this in with some other styles of animation and then connect it into the activity builder. So right now, he's just stuck in the middle of the frame. Okay, the window here, he's kind of just hovering in the middle, and that's not really what would happen in real life. As he was flapping his wings, he'd move up and down, and you'd have a little bit more movement. So what I'm going to do, I'm going to close the character folder up, and I'm going to make my mathy stuff folder. And this is where some of my extra movements might come. When he's flapping and using his wings, he's probably going to be moving up and down. So I would want that movement to be represented by a sine function. And what I would like to take the sine function of is that GIF time. And so right now you can kind of see it's just varying with the output. Maybe let me call this hover of x. Okay, so visually we can kind of see that it's going up and down. This is still kind of slow because GIF time, remember, is going in real time, 1 unit per 1 second. And so maybe I could speed this up so he's not going so slowly up and down. So I would want to multiply that by GIF speed. And actually, maybe I want to take GIF speed and slow it down a little bit. And we'll have to kind of see once we hook the dragon up if that looks all right. But literally, I'm probably going to connect the center of the dragon to the dot that you can see on the y-axis there. And this is fine as long as you want your dragon kind of in the center of the frame. I might want him a little bit closer to the water, and so I'm going to drag him down a little bit by subtracting 3. So in order to connect the dragon itself to that up and down movement, I need a point. So I'm just going to call this point center. And I want him to be centered at 0, but then I want him to be hovering at that 0 position as well. Oops, not hovering, hover. Okay, so we created this purple point, and that purple point is going to be the center of all of those different images that are locked into that GIF animation. So I'll come back to my character folder, and where it says 0, 0, that's static, I can go ahead and put center. And the nice thing about creating your point outside of each image layer is that you can change all of them all at once if you have to like edit things. So if I didn't want it to be moved down 3, I only have one line to type in as opposed to going into each image and changing the plus or the -3 to -2 or whatever it might be. So they are all going to be locked in at that center point, which I defined outside here in my mathy stuff layer. Okay, so for example, if I didn't want that -3, I changed my hover and he goes back to being centered right at the origin. -3 is kind of, I don't know if I like that. Yeah, -2 seems a little bit better. All right, so when your students get to the activity builder, when they're in your activity, as soon as they get to that slide, this is what they're going to see. The dragon flapping his wings and going back and forth. Time, the GIF time, because I said play indefinitely, will always be going no matter what. And so if you leave a graph for a long period of time and you come back to it, your GIF time or whatever you name it is probably going to be in the thousands because it's just been running in the background. It never stops, which is kind of interesting. The one thing that I would like to do maybe past this is put a little reflection in the water. because as he gets closer to the water, you would be able to see the reflection of the dragon itself. And so that'll be kind of interesting. That'll be cool. Not something you would maybe think about right away. So in order to do that, I'm going to go ahead and put in those 4 pictures again. And the thing that I'd like to do maybe with the reflection is change its opacity. When you look in the water, it's not a full-blown like image that you would be able to see. It's kind of translucent and transparent. So let me change the opacity by making a slider. And that slider here needs to go from 0 to 1. And we can go ahead. And the opacity of these last 4 images is whatever my slider tells it to be. Ooh, I actually forgot. I'm going to need to hook these up to each frame. So as it's animating up and down for the original dragon, the reflection of that dragon has to be doing the same thing. So actually, opacity isn't quite the full thing. So this is frame 1. I need to make it conditional. So if frame equals 1, then I want it to be opacity. Oops. Otherwise, I just want it to be invisible. So that is actually the code that I need to put in each box, and just change the frame number to go with the layer. So not only do we have 1 GIF going, we actually kind of have 2 GIFs in this video, which is, you can do as many as you want. You can really have a whole scene of things together. Now, it's still stuck in the middle. We'll change the center here in a second. The thing that I probably want to do is I want to flip him. The reflection is going to be upside down. And so his width will be the size that I determined. But when you look at the height's actually upside down, and so we need to negate the size. So all of these are going to need to be changed from 10 locked in to being size and negative size. Lots of little things to think about. If you haven't done this type of thing before, there's kind of a process of discovery, which is satisfying. So now he's upside down, but he's still stuck in the middle. And so we're going to create this reflection center. I might just call it reflection, but that reflection center point is going to be moved down kind of on the water of the image. So I'm still going to have it stuck at 0, but it needs to be hover of 0, and then we're going to subtract it down. I don't know, we'll say 9 or something like that. And the reason it didn't do anything yet is because I haven't hooked that center point of each image up to reflection yet. I'm wondering if the hover actually needs to be reflected. Oh, there we go. So you can see the point there kind of moving in the opposite direction. As it gets closer to the water, the point gets closer. So subtracting 9, probably not as far as I need to go. Maybe I can just go 8. So let's see kind of what that looks like once I tie each center of the reflection up to reflection. Nice. So yeah, my only complaint would be at the very end it looks like their toes touch, so I might do 7.5. Oops, it needs to actually be 8.5 further down. Not bad. So sometimes it takes a little bit of fiddling around with a certain amount if you want to move it up or down or left or right. But that looks pretty good. So you have the actual dragon, and then you have the reflection of the dragon coming in. And small things like that make the scene more believable, or just you appreciate the complexity that real animators have to go through sometimes. So I think that's good with our character and the reflection. I would maybe like to tie this up to another action of some sort. So I mentioned in the introduction that you can have layers of time, and right now I have the GIF time just constantly going. In the activity builder, it would be good to have maybe a button that sends the dragon flying away. Okay, and so that's what we're going to maybe try to hook up next. And I know that sounds complicated, but it's really just putting this video on top of the prior video. And so in my Matthew Stuff folder, I'm going to go ahead and create just time. Okay, and this time is what the activity layer is going to push through once they click the button. And so right now time is just 0. And if you watch my last video, I typically go 0 to 20. And the reason I do that is because playback speed in Desmos is a little picky. Okay, so this will give us a real-time preview of what we're doing. Now, in order to maybe make the dragon fly out, it needs to be stuck in the center of the image, and when they click the button, I'm planning on it flying off to the left, because that's the direction he's facing. And so you can do that fairly easily back here in the center point. If I just go ahead and subtract time, okay, you'll notice this actually needs to also go in as the x value of the hover function. When I play time, he's going to fly out of the window very slowly, and that's because time is not increasing very fast. And so to adjust this, I'm going to go ahead and have a speed value as well. So I have time in here, and then I have speed, which is kind of why I save these for when I know I'm hooking it up to the actual computational layer. So the speed might be 1 from 0 to 10. So maybe I'll play it at 5 times speed. But that also needs to go back up here. So when we have 0 and we're subtracting time, that forces the image to move left, because you're only going to get more negative, but I need to multiply that by speed. And so that little piece needs to go in both the x and the y. And again, if you can't see your line of code, or whatever you're typing in here, you can just expand that. So let me go ahead and let's play time again. Much better. Okay, so that might have been a little too fast. Now, I don't know if you kind of are complaining about his reflection hasn't moved. And so we're going to have to do the same process with the reflection. But if you can get it with the center, you can get it with the reflection, because it's just the same thing upside down. Yeah, so 2 times speed actually I think worked. So we're going twice as fast. It would be maybe nice, so right now he's staying kind of static at the same altitude, the level, as he's going out. It'd be cool if he's flapping, actually, if he kind of takes off out over the water. So the thing to adjust here would be the height of the center, and to make it go up faster and faster and faster, I'm going to go ahead and do time squared. We're going to make it a quadratic amount, and that'll just kind of increase as you get further in time. He's going to fly up in height faster. So that's not bad. I might smush it down a little bit. That way he gets out of the frame on the left. So maybe it's a 0.5 amount. And the nice thing about time is if you really wanted, you could just slide the slider, but playing it sometimes works just as well. So that's pretty good. I'm not going to complain too much about that. So in the reflection, we're going to do something similar, except it's going to be negated. The heights are going to be all flipped upside down. So let's go ahead. We'll copy that down to the reflection value. We already subtracted the reflection down to make it appear underneath the dragon. I'm getting a little bit of error here. Why is that? Because there's a comma. Double commas. Don't want that. So now the only thing that I need to kind of deal with is the quadratic amount. So as the dragon gets further away from the water, the reflection kind of recedes as well. And so I'm going to go ahead and subtract that quadratic because it's negated, and I'm subtracting that 8.35, which is what I moved it down. So if I play time, yeah, you can see that reflection actually already kind of bolted. I don't know if I like that. Let's reset that. When you can see that reflection, it's kind of mirroring what the original is doing. Instead of having 0.5 time, maybe I'll make it 0.15 time. And that way it sticks around just a little bit longer. Can't really see it anyway. Oh, what am I doing? I forgot to make my background 20. Everything seems so small. I wonder if that's going to screw stuff up. So I don't usually deal on small scales. I like to go tens in all directions, just because that gives you a little bit more space. In class, that's what I usually require kids to graph at. So if we play time from the beginning. Oh, my dragon's so small. Okay. So we'll make his size a little bit bigger. And then actually we're going to have to move him down more. So the nice thing that having a center point all by itself and having that entered into all the other images that you're doing in your GIF is that you just have to change things in one spot. So the hover probably could be moved down a little bit more, maybe almost 5. Yeah, and that means the reflection needs to be moved down way more. Okay, we'll play time. Yeah, and you can see that reflection a little bit longer as the dragon skedaddles. Okay, so I think that's pretty good. We'll just go ahead and clean the actual image up by turning off the grid and the axes. It's the last thing I do because it's important to have. And then go ahead and save this under something that's valuable to you. And we're going to grab the link here once it saves itself. And we're going to head over to the activity builder. So teacher Desmos. We'll go to activities, and we're just going to make a new activity. Trying again to make this available to everyone, so we'll call this episode 2, The Phantom Menace. No. My typing is not as good as the first video. I feel ashamed of myself. So starting from scratch here, I usually put a note in so I can tell kids what to be doing. And then the actual graph itself is going to go next to that note. So we can click into that graph. We can just paste the original that we did outside in the graphing calculator, and it will import that for us. We just hit done. Just keeping in mind that time is going to be the important piece of that. And so we'll call this dragon graph. Okay. The note. Let's go ahead and let's make that a little bit more fun. I have some stuff already written out, so click on the button below to make the dragon fly away. You know, But actually, yeah, we might do some coding in the note. That would be kind of fun. And then we will need a button. So let me put some enters in there. So that might be the last thing. That's some extra stuff. So fly button, and we'll say, be gone, terrible beast. So what we need to happen is when we hit the fly button, we need time to actually start back here in the dragon graph. And so if you remember from that first video, we need to go ahead and set our bounds. That way the window is locked in and you can't get all the weird like off-screen stuff that happens. So it's bounds, make bounds. And then because I made my picture a little bit bigger at the end, I know that it's going to be -10, left 10, and then +10, meaning right 10, -10, down 10, and then +10, up 10. Okay? So that's going to lock it in. You cannot change that because this computational layer is telling the component what to be showing you. So it's important to kind of know what you've already created and know what those boundaries would be. And then we're going to create a number. And in my last video, I forgot to mention that there are two ways to write the name of the number that you're creating. And so in this video, I'm going to show you the other way to do that. But time in slant single quotes. Like, I don't know what they're called, but they're right below the tilde button. They're paired with the tilde button right above tab. And so this will make your variable orange, and that's kind of like math type for Desmos. It understands that to be like math stuff. The other way that you could do that is take the single slant quotes and replace them with purple double quotes, and it understands that to be a word. So you have words versus you have math type. Does not make a difference. I really don't know why both of them work, but it is what it is. So this time is going to be determined by hitting the fly button. Actually, it would be kind of nice to have a delay. So you might press the button a couple times and nothing happens. And so you get a little anxious and you start really clicking it. So let's kind of make a little bit more coding in this. When fly button dot press count is greater than 2. So if you press it the first time, press count is 0 initially. When you press it once, it's not going to do anything. When you press it twice, still not going to do anything. But when you press it that third time, we're going to go ahead and make time itself equal to how much time has passed since you pressed it that third time. So you have when the fly button is pressed for the third time, we are going to have the fly button and the time since pressed. Now in the first video, I cut time off, and I'm going to want to do that again here. Default, it's 10 seconds, but it took about 5 seconds for that dragon to get off of the window. Right now it's giving me an error because it says when the fly button is hit on the third time, I want you to start remembering time and putting that into the graph. But what do you do otherwise? And so otherwise, I just want it to be 0. I don't want it to do anything else. So once you click it the third time, and the fourth time, and the fifth time, and the sixth time, it's always going to start time over again. All right, so that should be good. We'll go ahead and we'll preview this just to see kind of what happens. So we have our dragon flying in the middle of the scene. Doesn't do anything. Still doesn't do anything. I'm getting, be gone. And so after that, he takes off. Uh-oh, 5 seconds wasn't long enough. So maybe I can go into my graph and speed things up. Since I changed my window, the size of my picture at the very end. Oh, don't delete things. The speed might need to be a little bit faster. All right, let's preview that. There we go. Okay, what else can we do? I probably want to disable it. If you preview this and you click a bunch of times and then you click again, it's going to restart the image. And that's kind of annoying. If you want kids to only be able to do something once or trigger something once, you can actually disable this button, which is a good code to have in here. And it's fairly easy. So we're going to say disabled. I'm in the button component. And we're going to disable this when this component, so you could give it the name and refer to the name, or you could just say this thing itself. And we're going to do that when this press count is greater than 2, I think. And it is important to preview, make sure things don't go wrong. So when I press it on this third time, that will trigger the button to be disabled, and it's going to trigger the animation to go. So now we can't reset things. Perfect. The only other piece that I could put code in would be the note. And that might be kind of fun. There's some tricks that you can do with notes to kind of show strings and words and things like that. So I might have a bit of encouragement to students. And so this is just going to be a little message. When the fly button dot press count is equal to 1. So when they hit this button the first time, I want to tell them, like, keep trying. The dragon didn't fly away yet. Keep trying, keep hitting that button. And so then I can maybe change the message. So when fly button dot press count is equal to 2, so when they hit it the second time, maybe like press it one more time. And then otherwise, so like if it was at 0, or if it was at 3 presses or 4 presses or whatever it might be, I don't want anything to show up. And so you can just put those quotes next to each other, and that'll be invisible essentially. And so I have encouragement just as something defined in the CL layer of this component itself. And one thing that I can do is refer to that code inside of the component by putting a $sign and curly brackets, money, money brackets there. And it pulls up the different things inside of that component. And so I can call on the encouragement and maybe put a couple extra spaces down below so that things are spaced out a little bit more. So if I preview this, right now there's nothing there, but I press it once, keep trying, press it again, press it one more time, and then press it a third time, triggers the animation, disables the button, and it goes back to being a blank screen, which is so cool. You can do so many things, just hook everything up. It's really fun. Hope you learned a little bit in this video. I know I did a little bit more than just animating in Desmos, but the newest stuff was up front, so if you didn't want to hang out, that is fine with me. But I hope that it exposed you to some of the more advanced styles of animating that you can do, having multiple streams of time and continuously animating something in the background, which is something I use in a lot of projects because it's easy to do and it's kind of fun. It really makes a nice finished product. But I really enjoyed putting this video together. Hopefully I'll be able to do a few more in the future. And as always, happy to answer any questions or have a discussion in the comments if you leave anything on this video or my other videos that I've done. So, as always, take care everybody, and we'll see you in the next video.